So, in the last lecture, what we had started doing was what are called loop transformations. I had started initially with a nonlinearity in the K1 infinity sector, and I showed how we can convert that nonlinearity, or we can think of that nonlinearity as a nonlinearity in the 0 infinity sector. So, in some way the K1 infinity sector, you expand it out so that it becomes the 0 infinity sector. Okay. So, today I will continue with that, but probably I will also revisit the K1 infinity and sort of try and wrap it around nicely. Maybe what we will do is we will continue with what we were doing in the last lecture, that is after we had finished the K1 infinity sector, we had started looking at the 0 K2 sector. So, let us think of a nonlinearity in the 0 K2 sector. So, we are thinking of a nonlinearity which belongs to the 0 K2 sector. So, what I mean by that is, so here xi is the input to the nonlinearity, phi is the output to the nonlinearity, and we have this line which has slope equal to K2, and what we are saying is that we have a nonlinearity which lies in the 0 K2 sector. So, it lies something like that. That is a nonlinearity. Okay. Now, that nonlinearity, of course, one could think of that nonlinearity as phi by psi. That means, at any point you take the phi and divide by psi, you get this particular sort of triangle, and of course, the slope, the tangent of the angle that it subtends is smaller than the angle by the slope K2. So, this is less than equal to K2, but it is greater than equal to 0. And then we could rewrite any nonlinearity in the sector by means of a quadratic form. So, the quadratic form that we could rewrite this as is the following. So, you take K2 xi minus phi. So, when you do K2 xi minus phi, so if I am thinking about this particular psi here, K2 psi is here and phi is here. So, this quantity here is positive. If I, on the other hand, take a psi which is negative, K2 psi is here, phi is here, and so this quantity here is negative. So, if I multiply K2 psi minus phi to psi, I would get something positive, but that is not the quadratic form that I am going to take. What the quadratic form I am going to take is, you see phi here corresponding to this negative quantity, the corresponding phi is also negative, and here the phi is positive. So, what I am going to do is, I am going to take the quadratic form given by K2 psi minus phi transpose phi, and this is going to be greater than equal to 0 for any nonlinearity that lies in this particular sector 0 K2. Okay. Now, so suppose now you have this original nonlinearity and you have the input psi and the output phi. Okay. We want to convert it into a nonlinearity which has as its output, it has exactly the same output as the original nonlinearity, but its input is modified, and this new input psi tilde transpose phi greater than equal to 0, this psi tilde is given by K2 psi minus phi. Okay. So, how to modify this so that the psi tilde becomes K2 psi minus phi. Okay. So, the way we are going to do it is the following. So, let me put a gain here which is K2 inverse. So, if I put a gain here K2 inverse, then what should have been here is k2 times psi. So, k2 psi multiplying k2 inverse will give me psi. Now, I have to get this k2 psi, and so what I do is I take this phi, okay, and I feed it back here with a positive sign. So, I am adding phi to something, so that I get k2 psi, and so the something to which I have to add phi to get k2 psi is k2 psi minus phi. And now, if I think of this nonlinearity in the box, which is this nonlinearity with this gain and this feedback, then this nonlinearity has as its input k2 psi minus phi, and it has as its output phi. Okay. And therefore, this nonlinearity by this equation or this equation is therefore a passive nonlinearity. Okay. So, the transformation that I do for something in the 0 k2 sector is in this way, and when I do the transformation in this way, I get this new nonlinearity, which has the original nonlinearity as psi as the input and phi as the output. The new nonlinearity continues to have this phi as the output, but it has k2 psi minus phi as the input. Okay. Now, if we are now looking at the feedback structure, where you have a plant GS and you have this nonlinearity, and this nonlinearity is in the 0 k2 sector, and we are looking at this feedback connection between the linear plant and this nonlinearity. We modify this nonlinearity to that new thing. So, the new nonlinearity is obtained in this way. You have a gain here k2 inverse, and whatever is the output, you feed back a unity feedback with a positive sign. Okay. So, that what you have here is really k2 psi minus phi, and the output remains the same phi. Okay. So, here you have psi phi, and this is u, the input of the linear plant, and the output y. So, let me call this new plant that I have here, which would be a modified version of this plant. Let me call that G2S. Okay. So, the G2S has as its input the same as the input of GS, but it has as its output this k2 psi minus phi. Okay. Let me, instead of calling this u, let me just call this minus phi, because this u is equal to minus phi, and here y is equal to psi. And here what I should have is k2 psi minus phi. Therefore, the new plant that you get there, G2, is output by input. So, it is k2 psi minus phi divided by minus phi. From here, you know that G is psi divided by minus phi. So, if you now evaluate this, this turns out to be k2 times G, this transfer function, plus 1. Okay. So, now if you had a linear system with this nonlinearity in the 0 k2 sector, and you look at this closed loop system, this is exactly the same as looking at this modified nonlinearity along with this plant G2S, but this G2S is really k2 times G plus 1. Of course, how do we realize k2 times G plus 1? If you had the original G, you can put a gain of k2 in series with it, okay, and this plus 1 you can get by having a unity feed forward. So, G2S is really this net transfer function. So, if you see, just like in the last case, you have some sort of a symmetry, because in the nonlinearity you are putting this K2 inverse and then you are having this feedback, which is a positive feedback, and therefore, GS will also get modified, but this time the gain that you have in series with GS is going to be positive K2. I mean, it is going to be K2, whereas with the nonlinearity you had K2 inverse. And here in this loop, in this portion, in the nonlinear portion, this was a feedback. So, out here it is a feed forward. If you recall, in the K1 infinity sector, we had used a feed forward in the nonlinearity, as a result of which you had a feedback in the linear plant. Here in the nonlinearity you are using a feedback, therefore, in the linear part you will have a feed forward. Okay. Now, this kind of transformations go under the name of loop transformations. Okay. Now, by doing this loop transformation, you have got a new nonlinearity here, and this nonlinearity is passive. This whole thing that I am marking, this whole nonlinearity is passive. Therefore, this G2S, this modified linear plant, if this modified linear plant is strictly positive real and it is stable, then the original plant along with this nonlinearity, of course, if this is strictly positive real and is stable, then this resulting feedback system is going to be asymptotically stable, and that is the same as saying that this particular system is asymptotically stable. Okay. So, therefore, from this what we can conclude is, if you have a nonlinearity and you have a linear plant GS and you are looking at this feedback structure, and if the nonlinearity lies in the 0 K2 sector, then this resulting system is asymptotically stable if K2 times G plus 1, this transfer function, which is a modified transfer function that GS becomes, because you have modified nonlinearity these two are equivalent, and the modified G is K2G plus 1. This is positive real and stable. So, what we are really doing is, when we are looking at nonlinearities which are in sectors which are really in some sense subsets of the earlier situation, means initially the passive theorem, passive lemma and so on were proved for nonlinearities in the 0 infinity sector. Now, we are looking at something in the 0 K2 sector, where K2 is strictly smaller than infinity. Then one would expect more transfer functions to be interconnected to this nonlinearity, resulting in something which is asymptotically stable. Of course, if you have a nonlinearity in the 0 K2 sector, you see this is true, that all the nonlinearities in the 0 K2 sector, this is a subset of the nonlinearities in the 0 infinity sector. So, of course, if you take a plant here which is positive real and stable, then the resulting system is anyway going to be asymptotically stable. But what this result tells you is that you need not necessarily take GS, which is strictly positive real and stable, but you could take a GS such that K2 times GS plus 1, this resulting transfer function is positive real and stable. Okay. So, we could have a g which is not positive real or stable, and you could have k 2 g plus 1 resulting in something which is positive real and stable. And if that is true, then that g along with the original nonlinearity, that will again result in a system which is asymptotically stable. Now, I had used some sort of quadratic forms. So, let me just revisit these quadratic forms, and there are I mean depending on the tastes of people, there are new additional definitions given to many of these systems. So, when we consider the nonlinearity in the k 1 infinity sector, okay, when we had looked at a nonlinearity in the k 1 infinity sector, what this means is the output of the nonlinearity divided by the input lies between infinity and k 1, okay. And then this I could rewrite as phi minus k 1 psi transpose psi being greater than or equal to 0. So, this inequality that I have here of a nonlinearity in this class, I could write it in this way, and this then I could rewrite in this particular way. And then when I rewrite it in this way, I could think of, so the original nonlinearity was there with input psi and output phi. So, I retain the input as it is, but the output I modify to phi tilde, and so I look at it this way, where phi tilde is given as the original phi minus k 1 psi, and then this new modified nonlinearity is passive. Similarly, when you take a nonlinearity in the 0 k 2 sector, then the inequalities similar to this, the inequalities that you would get is the output by the input is less than k 2 and is greater than 0. And in this particular case, what I did was I kept the output the same. So, and I wrote this inequality in quadratic form, and so the quadratic form that I wrote was phi and multiplying phi multiplied k 2 psi minus phi, and this is greater than or equal to 0. And this k 2 psi minus phi, I defined that as the new input. So, I kept the output the same, but I modified the input, and so psi transpose phi greater than or equal to 0, where psi tilde was given by k 2 psi minus phi. Okay. So, what I am really doing is I take a nonlinearity in this sector, there are these inequalities which are satisfied, but that is equivalent to saying that it is this particular quadratic form that is satisfied. And if this quadratic form is satisfied, and I think of a new nonlinearity which has phi minus k 1 psi as the new output, I keep the input the same, I change the output, then this new nonlinearity will actually be, this new nonlinearity would actually be in the 0 infinity sector. Similarly, if I take something in the 0 k 2 sector, this is one way to define it, but I am redefining this in the quadratic form, and if I redefine this in the quadratic form, I think of this here as the new input. So, I keep the output the same, I change the input into this new input, and then the resulting system is again in the 0 infinity sector. Okay. Now, if you look at this case, nonlinearity in this case, then what we are doing is we have kept the input the same, but we have modified the output. Okay. On the other hand, if you look at a nonlinearity in this sector, we've kept the output the same and we've modified the input. Now, the way we modify the output in this particular case is we give a feed forward, the original plant we give a feed forward. Okay. So, such systems are also sometimes called input feed forward passive. And similarly, these systems, what we did was we kept the output the same, but we gave a feedback from the output, okay, and therefore, these are called output feedback passive. Okay. Now, these are all definitions, but the important thing to realize is that whenever you have some nonlinearity in some sector like K1 infinity, you can convert it using this quadratic form into something which is passive. And similarly, if you have some nonlinearity in the 0 K2 sector, then by modifying the input, this is the quadratic form that it satisfies, and so if you modify the input, then the new nonlinearity that you create is in the 0 infinity sector. And once things are in the 0 infinity sector, then you know that if you put a positive real stable plant in a feedback loop with such a nonlinearity, you get asymptotic stability. So, whatever was the linear plant that you connected, that will undergo a transformation to be a new linear plant which you associate with this particular nonlinearity, and that new linear plant should now be positive real and stable, and similarly in this case. Okay. Now, of course, we could also look at a nonlinearity which is in a bound K1 K2 sector. So, one could look at M, some nonlinearity in the K1 K2 sector. Okay, so what do we mean by that? This is the input, this is the output, and let's assume this has slope K1 and you have another line which has slope K2, and what we are saying is that we have a nonlinearity which lies in the K1 K2 sector. Okay. Now, for a nonlinearity that lies in the K1 K2 sector, we can again write some sort of a quadratic form, but and then use that quadratic form to convert this K1 K2 sector into the 0 infinity sector, that means passive. Okay. Now, one way to go about doing this is what one could do is we could convert this K1 K2 into a 0 K sector. Okay. And how does one convert this into a 0 K sector? Well, you have this nonlinearity with input psi and output phi. Okay. And now, if you think of the input as this psi, the output is this particular phi. Okay. What one does is we modify the input to the new input psi tilde, which is given by what we do is for the same psi, you have a new output phi tilde, which is given by the old phi minus K1 psi. Okay. How to do it here? Well, what we are doing is the new, so this is the phi tilde. Now, what can we say about this new? What can we say about this new nonlinearity? That means this nonlinearity which is there in the box. Well, what we can say is that this new nonlinearity whose output is phi tilde and the input is psi, this new nonlinearity belongs to the 0 k sector, where k is k 2 minus k 1. Now, it should be clear why this is k 2 minus k 1, because you see we are talking about nonlinearity in this sector. So, one of the worst cases would be, I mean, we could really think of the nonlinearity as a linearity which is output is k 2 times the input. Now, when we put this transformation, then the output becomes k 2 times psi minus k 1 times psi, which is k times psi. And so, what we have effectively done is we have rotated this round, and so the new nonlinearity that you get is psi is the input, phi tilde is the output, and you will have slope k, which is k 2 minus k 1, and the nonlinearity now will lie like that. Okay. Now, once you have something in the 0 k sector, we can use this particular thing to convert it now into something in the 0 infinity sector. Okay. So, what do we do? Well, to the nonlinearity, you put k inverse here, and then whatever is the output, you feed it back. Yeah, and you feed it back with a positive sign, I believe. Be sure, yeah. Okay, and now the phi tilde, but now we have modified the input also, and it has become psi tilde. Okay, now this new nonlinearity with psi tilde and phi tilde is in fact in the 0 infinity sector. All right, so okay, so here are some transformations that are going around. You have a GS, and you have this nonlinearity. Okay, and this nonlinearity is in the K1, K2 sector. So, you do the first round of transformations, and so you get this new nonlinearity. So, the new nonlinearity you get is the old nonlinearity with a gain of k 1 put here. So, this is the new nonlinearity. Instead of this, we have put this additional thing, and as a result, this GS gets modified. And how does GS get modified? Well, the GS gets modified by a feedback. Okay. So, now this is equivalent to this, where you have modified the nonlinearity and you have modified the plant. Okay. This nonlinearity which is there in this dotted box that I am talking about, if I call that nonlinearity NL1, this NL1 belongs to the 0 k sector, where k is equal to k 2 minus k 1. Now, this is further modified now in the following way. So, you have nonlinearity, you have this k 1, okay. So, this is the nonlinearity, and now you put in k inverse here, and you take a positive feedback, and this new nonlinearity that one is having, let me call this new nonlinearity NL2. This belongs to the 0 infinity sector. And of course, when you do this, you have to do the corresponding change in the transfer function, and the change would be, so you have the linear plant, you had the feedback, Okay. And then you do exactly this, but here you multiply by k, and then you feed forward, unity feed forward, and this is the resulting linear plant that you have. So, this is equivalent to this is equivalent to this. So, if Gs with this nonlinearity in the K1, K2 sector is to be stable, then this linear plant with this nonlinearity, this must be asymptotically stable. Okay. But what is this? This one could get from this by the transformations that it has to go through. So, if I call this linear plant G1, then I know G1 is equal to G upon 1 plus K1G, and then this G1 gets converted to this one. So, if I call this linear plant G2, so G2 I know is K times G1 plus 1. So, substituting G1, this is the same as K times G upon 1 plus K1G plus 1. This is the same as 1 plus K2G upon 1 plus K1G. So, if one is given a nonlinearity in the K1, K2 sector, and we are asked to find out all the linear plants which, when interconnected with this nonlinearity, gives rise to a system which is asymptotically stable, then we could do a loop transformation on this K1, K2 and convert it into a nonlinearity in the 0 K sector, and that is this thing. But what that would mean is this G will get modified to this G1, which is G upon 1 plus K1G. And then something in the 0 K sector, you can convert it into something in the 0 infinity sector. That means you can make this nonlinearity, convert this nonlinearity into a passive nonlinearity by this additional, the additional thing that you do here, some output feedback. Now, once you do this, the linear plant will also have to be modified accordingly, and when the linear plant is modified accordingly, then this linear plant is modified to this linear plant, but that is saying that this linear plant G2 is K times G1 plus 1, but then G1 itself was dependent on G. So, when you put all of them together, you get 1 plus K2G upon 1 plus K1G. Now, so theoretically, if you are given this nonlinearity in K1, K2 sector for any given plant G, you could calculate 1 plus K2G upon 1 plus K1G and check whether this plant is positive real. And if it is positive real, then the original system is asymptotically stable.